Let f of x be a continuous function on the interval 2, 6, and suppose that f of 2 is negative 3 and f of 6 is 5. Which of the following statements must be true by the intermediate value theorem? Well, the intermediate value theorem says that if I were to travel from point A to point C, that at some point I'm going to hit point B in the middle or somewhere in there. So if I were to look at this from a graphical point of view, okay, if I were to plug in 2, I'm down here at negative 3. All right. And if I were to plug in 6, I'm up here at 5. So I don't know the route that I'm going to take. I don't know if it's going to be all wacky and stuff like that. But at some point, if I travel from 2 to 6, I'm going to hit the x values of 2 to 6, and I'm going to hit the y values of negative 3 to 5. So what must be true? There must be some c value in between 2 and 6 such that if I plug in c, I get 0. Yeah, that has to be true. I have to hit 0. I don't have to hit 6 up here because 6 is above. I could, but I don't have to. There is no value that I get 1. Well, that's not true. I have to hit 1, so this is contradictory, and the function has a vertical asymptote. I don't even know. Okay, who knows? But I have to at some point hit 0 because I'm going from negative 3 to 5. And according to the intermediate value theorem, if my guy is continuous, I have to hit 0 at some point. Let f of x equal 1 over x. Can the intermediate value theorem be applied to f of x on the interval negative 1 to 1? Well, let's take a look at what 1 over x looks like just in case you forgot. This is the parent rational function. It's going to look a little something like this. Now, the intermediate value theorem says that if I were to go from like point A to point C, I would at some point have to hit like a point B somewhere in between. And that only works if it's continuous. Oh, look what I have, a non-continuous function. So can the intermediate value theorem be applied? No, because it's not continuous at x equals 0. A thermometer reads 58 degrees Fahrenheit at noon and 80 degrees Fahrenheit at 3 p.m. According to the intermediate value theorem, which of the following must be true? Well, the intermediate value theorem says if I'm going to go from 68 degrees to 80 degrees, at some point I have to hit 69 and 70 and 71 and all that stuff and all the things in between. And it has to happen between noon and 3. So let's make sure that I follow both of those criteria. I have to hit in between 68 to 80, and it has to be between those 2 points. So the temperature must have at some point reached 75 degrees between noon and 3, and already that is my answer. The temperature must have been exactly 85 degrees between noon and 3. Nope. In fact, it may not have ever reached 85. The temperature cannot have been less than 68 degrees during this period. It could have been. It could have gone from like 66 and then jumped back up. We don't know that. We don't know that. The temperature was increasing at a constant rate during this period. We don't know that either. So the only one that works is, yeah, at some point we must have hit 75 because according to the intermediate value theorem, this is going to be a continuous idea and you must hit that number in between. The continuous function g of x is defined on the interval 0, 4. The table below shows selected values of g of x. So equal input values, negative 5, negative 3, 1, 4, and 8. Based on the intermediate value theorem, which of the following values of g of x must occur for some c in between 1 and 3. So in between 1 and 3, I go from negative 3 to 4. So I need some number, like this is definitely going to hit negative 2 and negative 1 and 0 at some point, and all the decimals in between, and 2 and 3 and all the decimals in between. So at some point, I have to get a number in between negative 3 and 4, but not including. And so the number in between negative 3 and 4, but not including, would be 0. So at some point in between these guys, there must be a c that if I plug in for x, I get 0. It'll probably happen around here. And when that happens, I'm satisfying the intermediate value theorem. And I believe that is my last problem for Unit 1. Hooray! Like and subscribe, baby.